question. Let's see how we can do this. The first one is essentially U1, U2, fourth term of a convergent geometry. Convergent means as infinity exists. So means that the multiplier has to be less than 1 because you want each term to be smaller than 1. Each term to be absolutely smaller. Geometric progression are consecutive terms of an AP. Okay, so this U4 consecutive terms of an AP. So means if you take, so this is AP, U2, and U4. Okay. So you use U because U's are typically GP. Now prove that the common ratio of a GP is this. Okay, so this is the fun part. So I repeat, this is an AP. Meaning to say, if there's a common difference here, you add it up, comes this. So how will you do this? Now, the whole idea here is not to introduce more things that you need. So just try and keep things as simple as you can. We just let U1, because this is a AP, right? A GP, right? So this is A. U2 is of course A times R lah. U3 is AR square. U4 is AR cube, right? U1 is A. So the first term, this is AR, and the fourth term is AR cube. Now once you get that, you realize that this is actually an AP because you just take out from GP and this is an AP ma. So it's told to you. So what we can do is that we know that the common difference D will be AR minus A, this minus of this, and also this minus of this. Take AR minus A and AR cube minus AR. This is something which I can form, right? This one here with this equation here. I can get rid of the A. I can express in terms of R. So this one here me. No. AR2 is AR, A times R. Yeah. A2 is AR ma. A4 is AR cube. U2 U4 minus U2. Because this is because this AP here, this he read the question probably, the first, second, fourth term of a geometric progression. So this GP here, you have U1, U2, U3, U4, and U5, and so on, right? What you say is, if you take the first, the second, and the fourth, this will be an AP. Yeah, is that right? So there are two layers here. One is the AP, one is the GP. So you from a GP you take the terms out, it becomes an AP. So that's why they're asking. They're asking you to show that the R is this form here. You just write it down. This one, show it. Is R minus 1. This is R cubed minus 2R plus 1. Okay? You can key calculator lah, but you get one of the solution as 1. So you see this 5 1. This is 1. Since R equals 1 is a root, so this one you can say that R minus 1 is a factor. Or because you need to find the exact root. You need to find the exact root. So actually what I'm going to do is actually just find here. This is like secondary school stuff, so I'm just gonna quickly do this. Okay, make sure it's a factor there. You key in calculator. You key in calculator for this one. So R3 is 1, 0 minus 2 and 1, right? Press enter. Go down there. One of the root is 1. You won't need to find the exact root. The thing is, R cannot equals to 1, right? R cannot be equals to 1. Because then the GP will just repeat itself, right? But we're also not very interested since we know that mod R is less than 1 because we want sum to infinity exists. So in other words, we need to find out the root from here lah. Okay, so we just solve it. It's algebra lah. So we just use the quadratic formula. Here will be r squared plus r minus y equals 0. So r equals to minus 1 plus minus b squared minus 4ac over 2a. So minus 1 plus minus root 5 over 2. Okay, which one to reject? Why? Okay, you know that is the one on the right, but you need to give the reason why you reject the one on the right. Reject as what? As calculator? As what? No, it's not. It cannot be negative. It can be negative. Yes, because you want it to be a mod r, which is which makes the next term smaller. Okay, this is minus 6. Okay, you see just now when we solve, right, 1 is negative 1.61. This one will make the term bigger because it's a magnitude of more than 1. Every term you calculate in, right, it will just make the terms bigger, right? So absolutely bigger. So let's look at, yeah, the other one is actually, let me show you. The other one is actually less than 1. The plus one is actually less than 1, you see? Yeah. So this is important. Let me just write down the value. Yeah. Okay. So proven. Is the first term of a GP is positive. So this first term is GP is positive. We now know that this GP, the R is the R here is R is 1. Minus 1 plus root 5 over 2, right? Okay. So that the sum of the first 5 terms, which is actually sum 5, is greater than 9/10. So this is 9 over 10. Sum to infinity. I think just show lor. Nothing fancy there. We just show. So the first term is GP 0. The sum of the first 5 terms of a GP is greater. So first, Okay, just need to show that S5 is bigger than 0.9 centimeter. That's about it. You can just key in calculator if you want to. Okay, but you can just here. So let me just write down. Yeah, many ways to do this. Really a lot. So here, since so this one here, yeah, I'll just sub into one. There will be you sub this is 1 to infinity here, right? You see this one infinity? S5 is equal. Right? So S5 is actually equals to R5. This is how I'll do it lah. You don't really need to follow me, but you can just key in calculator here. 5. Because it's a sum of the first 5 terms, right? So this is A1 minus R5 over 1 minus R. Okay, so then one 2, then this would be power 5.